and welcome to today's edition of Physics. Today, we are going to look at equilibrium of force. When is a body said to be in equilibrium? A body is said to be in equilibrium when the net force acting on that body is zero. That means that body is not in motion. Actually, it is not accelerating. For example, a body is said to be in equilibrium when the whole body is at rest or moving linearly with a constant speed. Yes, a body is said to be in equilibrium when the entire body is at rest or moving linearly with a constant speed, or when it is rotating with a constant angular speed, because a body that is rotating can also be in equilibrium when the angular speed is zero, or when it is moving linearly with the linear velocity also zero, or when it is at rest. Types of equilibrium. Generally, we have two types of equilibrium, which is static equilibrium and dynamic equilibrium. When is a body said to be in static equilibrium? A body is said to be in static equilibrium when it is at rest. That means it is not moving, it is solely at rest. You say that it is in a static equilibrium. Like, for example, this marker on my hand, it is in static equilibrium because it is at rest. Then the second one is dynamic equilibrium. When a body is said to be in dynamic equilibrium, a body is said to be in dynamic equilibrium when it is moving with a constant speed. That means that body is not accelerating, the acceleration is zero. You say that that body is in dynamic equilibrium. Equilibrant and resultant force. What is equilibrant and resultant force? You look, equilibrant and resultant force take place when we have some numbers of force in equilibrium. For example, when we have three forces that are in equilibrium, for example, F1, F2, and F3. If these three forces are in equilibrium, we can look at the equilibrant of the forces and also the resultant of the forces. Come over here, let's look at this diagram. This force still represents 1, 2, 3. They are in equilibrium at this point, zero, right? So, the equilibrant of this is a single force that keep other force in equilibrium. That is what is called equilibrant force. A single force that balances other forces, or a single force that keep other force in equilibrium. If you come over here, F3 is the equilibrant of F1 and F2 because it kept F1 and F2 in equilibrium. F2 is the equilibrant of F1 and F3 because it kept F1 and F3 in equilibrium. F1 is the equilibrant of F2 and F3 because it kept F3 and F2 in equilibrium. That is what we are talking about when we talk about equilibrant force, a single force that balances other forces. So let's look at resultant force. Coming over here, look at these two. Let's take it as this F1 and F2. This E, which is equilibrant, is this F3. Then a resultant force is a single force that its action in magnitude and direction is the same as the action of other forces taken together. For instance, this single force is a resultant of these two. We are trying to say that when this single force acts, both in magnitude in direction, it's equal to the sum of these two also acting. That is why when we say that a resultant force is a single force in which its action in magnitude and direction is equal to the action of other forces taken together. Like when this single one acts is equal to the action of these two, both in magnitude and direction. That is what we are talking about when we talk about resultant forces. So you have known about equilibrant and resultant forces, dynamic equilibrium and static equilibrium.